Hello everyone, welcome you all. Myself Vandana N from Sri Venkateshwara College of Engineering from Department of Electronics and Communication from first semester section Infinity subject I'm going to discuss here about chemistry on the topic of e-waste management. Content I'm going to discuss about here is introduction, sources, characteristics, effects on environment as well as human health, method of disposal, advantages of recycling, extraction of copper and gold from e-waste. Introduction. What is meant by e-waste? E-waste or a electronic waste is a electronic product that have become unwanted on working and have essentially reached the end of their useful life, which is called as a e-waste. Now sources where we are going to use the electronic devices such as TVs, computers, laptops, displays devices, and in telecommunication devices such as cell phones, calculators, audio and video devices, and electronic components such as sensors, alarms, sirens, security devices, and kitchen equipments. Like we are going to use daily as a coffee makers, microwave ovens, as well as the laboratory equipments or plates, microscope, microwaves, etc. we are going to use. Characteristics. E-waste is generally characterized by analyzing the component and composition of wastes. Hazardous components in e-waste. E-waste consists of a large number of components of various sizes and shapes which contains hazardous components that need to be removed by separation method. See, e-waste management. E-waste management like tubes, cathode ray tubes process we are going to use there as a breaking and removal of a yolk and then dumping and a potential environment hazards like lead, barium and other way metal leaching into the groundwater and release of toxic phosphorus in such a way that we are going to use e-waste components. And now I'm going to discuss about disposals. Landfilling. First we come across with the landfilling. This is the most common metallurgy of e-waste disposal. Soil is excavated and trenched or made for burying the e-waste in it. It is not an environmentally sound process for disposing of the e-waste as a toxic substances inside the soil and groundwater. Incineration. This is controlled way of disposing of the e-waste. This is the main this is the process where we are going to control the e-waste. It involves combustion of electronic waste at high temperature in uh, in special in specially designing incinerations. See here, first we are going to see that land filling, and second we are going to see about incineration. Now toxic materials that are used in electronics and electrical products. See, the main hazardous substances that could be found in electronic products are lead, mercury, cadmium, zinc, deuterium, chlorium, beryllium, nickel, bromide, flame retardation, antimony trioxide, etc. We are going to use that. And wet chemical like including acetic acid, acetone, ammonium fluoride, ammonium hydroxide, hydrochloric acid, hydrogen peroxide, isopropyl alcohol, nitric acid, phosphoric acid, and sulfuric acid. See here, now next we are coming to the health hazards due to exposure to e-waste. Due to e-waste, what are the problems you are getting? See that reproduction issues, developing developmental process, damage to immune system, kidney damage, may lead to lung cancer, skeletal system damage, and etc. We are going to uh, get a problems from e-waste. Recycling and recovery. Recycling and recovery. Recycling of e-waste, it involves the reutilization of e-waste with the help of recycling process. This method involves dismantling of electronic devices, separation of the parts having a hazardous substances like PCBs, and then recovery of the precious metals like copper, gold, lead can be done with the help of e-waste recycler. Reuse. This is the most desirable e-waste recycling process where with modification the mobile phones, computers, laptops, printers can be reused or given as a second land product. See here how we are going to use this. First of all, we are going to use e-waste, and next we come across with the pre-treatment, and come across with the hydrometallurgy, prometallurgy, and biohydrometallurgy. In pyrometallurgy, calcining, roasting, smelting, refining is taking place, and in hydrometallurgy, leaching, purification, separation is taking, and in biohydrometallurgy, leaching, separation, adsorption is taking place. Next is metal recovery. In this way we are going to recycle the metals of e-waste. Pyrometallurgy. Pyrometallurgic process are the most common method for the recovery of previous metals from e-waste. Usually the metals are in complex matrix with one another other non-metallic materials, and it is very difficult to recover them through physical separation method. The pyrometallurgical methods are beneficial to segregate and concentrate the metals from e-waste. It is the mostly used to recover the copper content of e-waste and other metals that dissolve in molten copper such as Ag, Au, platinum, and palladium. Next step is hydrometallurgical process. This process can be broken down into leaching, solution concentration, or purification and metal recovery. And the general procedures as follows here. First, we have come across physical treatment. Prior to the hydrothermal process, physical treatment such as sorting, dismantling, and size reduction are performed to produce the granular from the waste materials. And leaching, by leaching, the leaching process involves the extraction of soluble components from solid or by using a agent acid, alkali, and the valuable metals are converted into soluble salts, while impurities remain insoluble and be removed with the gang materials. The most common leaching agent for the recovery of previous metals are cyanide, alide, and thiourea and thiosulfate. And the efficiency of a leaching depends on the particle size, amount of a leaching agent used, temperature, contact time between the solids and the liquids. Next, separation and purification. The solution are then subjected to the separation and purification process such as adsorption, solvent extraction, precipitation of impurities, ion exchanging, etc. To isolate and concentrate the uh, previous metals recovery, the metals are finally obtained by treating the solution by hydro refining process, chemical reduction, or crystallization. Next, come across with the extraction of gold from e-waste. It involves in the three steps: pre-treatment stage, chemical treatment stage, metal recovery. First, we are going to discuss about the pre-treatment stage. It involves the physical separation of a metal component from the e-waste, and technique used are gravity separation, electrostatic separation, magnetic separation. The next, chemical treatment stages. It involves the leaching the targeted metal by treating with appropriate chemical reagents. The cyanide leaching is the most common method used to extract copper. Uh, Next, H2SO4 or HNO3 is used as a leaching solution for the extraction of copper. When e-waste is dissolved in H2SO4 or HNO3 in the presence of an oxidizing agent like H2O2 gives copper solution. CO copper plus half O2 plus 2H, which gives rise to Cu2 plus H2O. Next, metal recovery. Metal recovery stage. In this stage, copper metals can be recovered from the obtaining copper solution using method like electrode deposition, solvent extraction, ion exchange, precipitation. And if example for the metal recovery stage is electro deposition. In this method, pure gold metal taken as a cathode and inert anode are dipped in obtained leached complex solution. When current is applied, gold is electro deposited on cathode. Thank you everyone. Please share and subscribe to my YouTube channel.